Europa is 3,100 kilometers across, but its hidden ocean may hold more liquid water than all Earth's oceans combined. Does Europa's ice-covered ocean have the ingredients that could make alien life possible? Europa is one of Jupiter's four large Galilean moons. From orbit, it looks like a pale ball covered in dark cracks. The surface is water ice measured by spacecraft and telescopes. The ice is young in geological terms, with few large craters, so the surface has been renewed since much of the early solar system bombardment. Beneath that crust, the best explanation for several measurements is a global salty ocean. It has not been seen directly. It is inferred from Europa's gravity, its surface geology, and the way it interacts with Jupiter's magnetic field. The strongest evidence comes from magnetism. Jupiter's magnetic field sweeps past Europa as the moon orbits. A conducting layer inside Europa responds to that changing field and produces an induced magnetic signal. Solid ice is a poor conductor. Salty liquid water is a much better one. The measured signal is therefore consistent with a global ocean under the ice. The exact thickness of the ice remains uncertain. Estimates range from a few kilometers in some models to more than 20 kilometers in others. The ocean below it may be tens to more than 100 kilometers deep. Liquid water makes Europa interesting, but water alone does not make a habitat. Life, as known on Earth, also needs usable chemistry and a steady source of energy. Europa has no sunlight at the seafloor. If life exists there, it would have to rely on chemical energy, not photosynthesis. Chemosynthesis means building food from chemical reactions instead of light. On Earth, that kind of life exists around hydrothermal vents, where seawater moves through hot rock and returns carrying reactive chemicals. Europa may have the same broad setting if its ocean touches a rocky interior. The energy source is Jupiter's gravity. Europa's orbit is not a perfect circle, and the pulls from Jupiter and neighboring moons flex its interior. That flexing produces heat. The evidence supports tidal heating as a way to keep Europa's ocean liquid over long timescales. It may also drive geological activity in the ice shell. Whether it heats the seafloor enough to power hydrothermal circulation is not known. Models allow it, but models are not measurements. The question is now narrower. The ocean needs water, rock, and energy in contact for long enough to sustain metabolism. Europa's surface receives intense radiation from Jupiter's magnetosphere. That radiation can split water and other molecules in the ice. This process, radiolysis, can make oxidants, chemicals that can release energy when they react with material from the ocean or seafloor. The surface therefore may be making useful chemical fuel. The unresolved part is delivery. Oxidants on the surface would have to move through the ice and reach the ocean. Some surface patterns suggest exchange between the ice shell and the ocean, but the rate and depth of that exchange are still uncertain. Several observations have suggested possible plumes of water vapor rising from Europa. Those detections are uncertain, and they have not produced a stable picture like the plumes seen at Saturn's moon Enceladus. If Europa has active plumes, a spacecraft could sample ocean-related material without landing or drilling. If it does not, the surface still may carry material brought up from below, but the connection would be harder to prove. A confirmed plume, repeated in the same place or tied to surface heat, would greatly strengthen the case for accessible ocean chemistry. Europa is now a target of dedicated spacecraft investigation. NASA's Europa Clipper launched in October 2024 and is planned to make dozens of close flybys of Europa after it reaches Jupiter. Its instruments are designed to measure the ice shell, surface composition, magnetic response, heat patterns, and particles near the moon. ESA's JUICE mission launched in April 2023 and will also study Jupiter's icy moons, including Europa flybys. These missions are not expected to drill into the ocean. Their job is to test habitability, how thick the ice is, what chemicals are present, and whether ocean material reaches the surface. The evidence supports a careful yes. Alien life could exist under Europa's ice in the limited scientific sense that the moon appears to have the main conditions life uses on Earth: liquid water, chemical ingredients, and possible energy from rock-water reactions. The evidence does not show that life is present. It does not yet show that the ocean's chemistry is rich enough, that oxidants reach it, or that hydrothermal activity is happening now. Those are measurable questions. A lander, a plume sample, or a future probe able to reach clean ocean material could move the answer from possible habitat to tested biology. That's why source. If this was worth your time, Like it, share it, and tell me in the comments what you want examined next. If you would like to support this work, the Patreon link is in the description.